factor 40c to the third minus 5d to the third. So there doesn't look to be anything obvious just yet. 40 doesn't look like a perfect cube to me, and neither does 5. But at least both of these terms are divisible by 5. So let's factor out a 5. So this is equal to 5 times, if you factor out a 5 out of here, 40 divided by 5 is 8 c to the third. You factor out a 5 here, minus d to the third. Now it looks a little bit more interesting, because 8c to the third is a perfect cube. 8 is a perfect cube, and c to the third is clearly a perfect cube. So this is a perfect cube. And so is d to the third. It's d to the third power. Now, once again, this is a special case. This is a special case. And I'll tell you the special case right from the get-go. It's a to the third minus b to the third, I'm just writing it in the general form, is equal to a minus b times a squared plus ab plus b squared. And just so you don't get it confused, the other pattern we know is the sum of cubes. Let me do that in a different color. The sum of cubes is a to the third plus b to the third, and that factors out to a plus b times a squared minus ab plus b squared. So when you have a negative sign here, this is a negative, this is a positive. When you have a positive sign here, this is a positive, and that is a negative. And we can multiply this out. We can multiply this out if you don't believe me. You have a squared plus ab plus b squared times a to the third, times a minus b. Let's multiply it out. So first you have the negative b times all of this business up here. So let's multiply the negative b times all of that. So we get negative b to the third minus ab squared, and then negative or let me write it this way, negative a squared b. So I just multiplied negative b times all of that stuff. And now let's multiply an a times all of that stuff. So a times b squared, so ab squared. A times ab is a squared b. And then a times a squared is a to the third. When you add them all together, these guys cancel out, these guys cancel out, and you're just left with an a to the third over here minus b to the third. So hopefully you now see that this does work out. And this is a very special case, difference of cubes. So we can just do pattern matching here. This 8c to the third, that is the same thing as 2c to the third power. And then d to the third is clearly this. Well, that's just clearly d. That's clearly d to the third power. So let's just factor this out. So this is going to be equal to, let's put this 5 out front. I'll put brackets here, so we could view these brackets as being right over here. And then this is going to be a minus b. A here is 2c. So it's 2c minus b. In this, when we pattern match, the b here is d. Here's b to the third. Here we have d to the third. So that over here is going to be d. That is going to be d times a squared. A, let me write it down here. A in our example, a is equal to 2c. And in our pattern, b is equal to d. So if we have a squared, that's 2c squared, or that's 4c squared, or 2 squared times c squared, either way, plus a times b, so plus a times b, plus 2cd, and then plus b squared, so plus d squared. And actually, I'm forgetting a parentheses over here. And we're done. And we know that we can get rid of those brackets. This is the exact same thing as 5 times 2c minus d times 4c squared plus 2cd plus d squared. And you can attempt to factor this again, but we won't do it in this problem. And it's actually not a trivial thing to do. And I'll leave you there. We have factored this as a difference of cubes.